Aspect ratio is a relationship from the chord width and the span of the kite. And the longer you make the leading edge, the more lift it's created. So chord width is drag. So if you have more chord width, you have more drag. So for a kite that you want to have sit further back in the window and do tricks like handle pass kind of tricks or wakeboard style, you want the kite to always be pulling, having a lot of torque. So you'll have a little bit lower aspect ratio kite. They're easier to fly, they're more stable. As you get higher and higher, I've made kites up to 10. And basically they're like this wide for a 12-meter kite. And the problem you have is stability. They don't like to handle the gust as well because you just don't have structure there. You have no structure to hold this whole thing together. But once you get them in the air, the lift that's created by them, the hang time that you can get, basically for every point that you go up, you gain half a second. So the difference between an aspect ratio of 5 and an aspect ratio 8 is seconds in the air. Profile, for example, right now, I'm using a profile that's around 10%. That means that the height of the profile is 10% of the chord length. And that's a pretty good number to work with for power, maneuverability. As you go higher, you create more drag, but you create a lot more power. So what you can do is you can make a 10-meter kite with 3 different profiles. So you could have one kite that would act like a 16-meter. You could have one kite that acts like a 12-meter and one kite that acts like an 8-meter, but they're all 10-meter area just by changing the profile. But that doesn't actually make the best kite because it doesn't give you the best range. So, yeah, profile makes a big difference. You can have reflex profiles, flat profiles, profile with the high point forward, back. And the surprising thing is the difference between a 10% and 9.75 is huge. It's a big difference. If you go from 10 to 7.5, that's a huge difference. And when you start looking at them in the profile simulation in the wind tunnels, you'll see how that all changes. Well, narrower wingtips make the kite turn slower and give you more power. Wider wingtips give you more D-power and faster turning. You can go to extreme where you're turning the kite too fast and they start to create drag. But every time you cut off the wingtip and you make it wider and wider and wider, you're changing the aspect ratio. So at a certain point, you get a lower aspect ratio kite because your aspect ratio changes so much as the wingtip gets wider. So there's a balance between the wingtip, the profile, and the aspect ratio. Those things all have to work together, and then you throw in the angle of attack. And only one angle of attack works with a certain profile. So they all work together. Everything's all balancing out. With windsurfing sails, everything was related to tension in the sail. The kite's the same. All those components that we just talked about are tension. And those tensions have to equal 1. And when they equal 1, you have the perfect kite. If they're 1.5 or 0.8, then something's wrong with the kite. You don't have the perfect kite. So that's what we're always striving for, is to find that perfect balance of those elements. Kite is amazing. I mean, recently we're flying on this, the same flying lines we kite surf with, on a 200-pound boat with 5 guys in it, totally overpowered, lifting the boat completely out of the water, and nothing breaks. We've had the kite on a 3,000-pound boat. Nothing breaks. Same kite you kite surf with can pull a 3,000-pound boat. And the reason is that the loads are all spread evenly through the entire kite. They're not just point loading on one point. It's an even spread. Flaps. I've been working on flaps for a couple of years now, and the interesting thing about flaps is that you can change the profile. So you could have a profile that creates no power, and you engage the flaps, and then it creates power. And this is going to be real interesting in the future for safety, because you'll be able to make a kite, that you can just walk up and down the beach and there's no pull. And then when you engage it, it creates full power. Your front lines are basically connected to the front toe point, and that toe point is related to the center of effort. And the further you go forward to the center of effort, the less power you have in the kite. So if you go too far, then you have to sheet in too much. And then you need more backline pressure, which puts more pressure into your hands and your arms. So the trick is finding the balance with the right profile, the right toe point position, the right tip width, and all those things have to work together in harmony. If one thing's off, then the kite's not feeling correct, and that's what we're always striving for, is to find that balance.